everybody. I'm Flavio Castelli from SUSE Rancher, and I'm here to talk about how to extend Kubectl by using WebAssembly. So this is a live-in talk. I don't have much time to go into WebAssembly, what it is, and other, nitty-gritty details, but I have a Q&A at the end of this talk, and you're more than welcome to reach out to me in any means by using email, Twitter, Slack, or whatsoever. All right, so let's get started, and let's take a look at how Kubectl plugins are currently created. So under the hood, they're basically executables. They're binaries for your operating system and architecture that Kubectl is just invoking. They are managed by a tool that is called Crew, which is a really nice tool. But at the end of the day, they are just binaries, which means that as a plugin author, I have to maintain a pretty complex build matrix so that I'm building my plugin for, Linux Intel, Linux ARM, macOS Intel, macOS ARM, Windows. So this can be quite a burden, I think. So by using WebAssembly, we can change that a bit and have other nice side effects. So first of all, I'm no longer building for all this mix and matches of operating system and architectures, but I'm just building for one target, which is the WebAssembly target. That's because WebAssembly, once built, it can run everywhere. You just need to have a WebAssembly runtime, and this is it. So for plugin authors, this simplifies things a lot. Then in terms of security, there are quite some improvements, because if you think about that, regular plugins, they are, as I said, binaries running on your machine. They are running unconfined. They can access your file system, create files, remove files, read files, all that kind of stuff. They can interact with other processes running on your machine. They can even start new processes. They can interact with devices like, your webcam. They can do network requests. So they can do basically everything. WebAssembly, on the other end, the modules, once executed inside of a runtime, they are located inside of their own dedicated sandbox. Each module is running inside of its own sandbox. It cannot see other modules running on the same machine, but what is even more interesting is it cannot see processes running on the machine. It cannot create new processes on your machine. It cannot access the file system of your computer, or if you want, it can access some portions of it that you choose. It cannot interact with devices. It cannot do networking operations. So it's way more secure if you look at that. So if we have a Kubectl plugin written with WebAssembly, the kind of damage it can do is way more limited compared to the one that a regular Kubectl plugin could do. Last but not least, in terms of binary size, the majority of the plugins of Kubectl are written in Go, which is notorious for adding, pretty big binary artifacts. With WebAssembly, on the other end, you have smaller binary size. So this is not the top priority, but it's a nice gain that we get. What is the main driver, at least it has been the main driver for me, is the fun aspect. So this has been, a really nice experiment, a way to push WebAssembly boundaries and WASI boundaries to try them with something concrete. And it was really nice. And as you can see, it also delivered something interesting. So what did I do? I created this tool called Crewosm, which is completely unrelated with the Crew tool I was mentioning before. It is not meant to replace it. On the other end, it's something that complements it. So Crewosm provides a way to manage these WebAssembly modules for Kubectl. It can download them. It downloads them from container registries. This is the way I envision to distribute these plugins. It provides a runtime for them. It provides all the necessary glue to make them discovered by Kubectl, to make them runnable by Kubectl. And yeah, that's basically it. So going back to the build matrix that I was talking about before, now as a plugin author, if you're writing a WebAssembly module, you just have one target. The complex build matrix is not your problem. It is the problem, it is the burden of the CrewWasm maintainers. So that's a really nice improvement, I think. Now let's see this tool in action to see what it is capable of. So we will start by listing all the Kubectl plugins that I have available on my machine. As you can see, I have a bunch of them. Now for the sake of this demo, I'm going to use a plugin that is called Decoder, and as you can see, it is not listed over there. It is not listed because this is not yet available on my machine. As you can see with CrewWasm list, I know I don't get it. So in order to obtain the plugin, I'm just going to download it from a container registry. And the only thing I have to do once this is done, I just have to do it once, is to make sure that this path is available inside of my path environment variable. This is it. Now, if I list the plugins with CrewWasm, I'm going to see the decoder plugin. But what is even more important is that if I list the plugins by using the vanilla kubectl, this is now available as well. So how does it work? How does it look like? Well, it works exactly like any other kind of binary that you can have on your system. It works like any other kind of Kubectl plugin. So I can run the -- help and get some useful information about it. It has some CLI flag. It has also a secret subcommand. So let's take a look at that one. So basically, this plugin is just providing a more convenient way to interact with Kubernetes Secrets. That's it. So let's see that in action. So first of all, we will look into a Kubernetes secret by using the vanilla Kubectl. And as you can see here, I get the data of this secret, which is base64 encoded. So this is not really convenient. What the decoder plugin is doing is just to decode this information back to something human readable, and this is it. So nothing fancy. However, what happens if we look into a TLS type of secret? With vanilla Kubectl, we get everything base64 encoded. But doing a base64 decode of all of that is not going to be useful either. What the plugin is doing instead, it is decoding the TLS data that is stored inside of it. So, for example, it shows the usual stuff, annotation and all of that, but then it finds a CA certificate, so it starts to look into the validity, who issued that, what is the subject, and a bunch of other information that are specific to TLS. And this is, I think, pretty useful. So this is a WebAssembly module that is actually doing something concrete, something that can be useful. It's not just an hello word, this is why I did that. So let's go back and let's take a look at what I learned along the way while working on this POC. So first of all, WASI, which is an extension of WebAssembly, is giving us a lot of really good things that we need. So we need to read stuff from the file system of the machine, like the Kubectl configuration file, and WASI allows us to do that. We want also to access the environment variables of the host, so that if the user is specifying a different kubeconfig, we can get it by reading this environment variable. We can also basically write CLI programs in a regular fashion without any change. I mean, this is like a regular, it's written in Rust, it's a regular Rust CLI application that is using regular Rust CLI libraries like clap if you're into Rust. And everything just works outside of the box. Actually, what is really powerful of WebAssembly, and this case Rust, is that I've used many Rust libraries inside of this demo, and all of them work out of the box without doing any change. If you think about that, what we have seen was CLI flex. It worked. We have seen fancy colors on the standard output, just worked. ASCII tables, they worked. We have seen the details about the certificates. They have been obtained by using a popular Rust library that deals with TLS certificates. So that just worked out of the box, and this is just amazing from my point of view. What is still a bit rough due to the early days of WebAssembly on the server side is the networking aspect. So there are no socket capabilities yet inside of WASI, but they are being added as we speak. And because of that, all the communication that happens between the plugin and the Kubernetes API server is a bit convoluted. So it worked, as you've seen. How did I make it work? Well, I had to instruct my runtime, CrewWasm, to offer some tailor-made capabilities to the plugins. And inside of a plugin, the big issue is that you have to find some libraries to interact with, I don't know, Kubernetes API server, Redis, Memcache, whatsoever, any kind of server. These libraries must focus just on the data that is exchanged, like what is the object that I have to create in order to create a pod. How do I decode a pod list response? That kind of stuff. All these libraries that don't have to focus on the networking aspect of exchanging packets. They are completely ignorant about that. This is an approach that is called Sans IO, which basically doesn't focus on how the IO is performed. It's an approach that has been created inside of the Python ecosystem for the first time, but can be applied to any kind of language. And so you must find a library that is capable of doing that. And actually, I've been extremely lucky because the Kubernetes library for Rust, the major one, is written using this approach, which allowed me to pull everything off. But these kind of libraries do not exist for other languages, and so that makes Rust the only good candidate for writing Kubectl plugins using WebAssembly right now. But this is going to change in the future. I have a lot of hope about that. So to wrap it up, these are the links to the CrewWasm project, the source code. You can find also pre-built binaries for it. The link to the decoder plugin I've shown, and also the link to the SDK that you can use to write your own Kubectl plugins using WebAssembly. This is it for today. I hope that was interesting for you. I hope I sparked your interest and your curiosity with this talk. So have fun. Bye-bye.
You write Kubectl plugins. So using WebAssembly, we have the ability to use Go, and we have the ability also to use Rust or whatever the. What would be your advice on someone who says, okay, I have some programming language skills. I want to write my first Kubectl plugin. Which language should I use to make it more efficient?
I guess you're still referring to this experience writing WebAssembly Kubectl plugins, right?
Yes.
Okay, yeah. Well, right now, unfortunately, the only language that can be used to do that is Rust, and that's because you would need to be able to interact with the API server of Kubernetes, and so for doing that, you require a library that is able to decode the responses that are coming from the API server. This is the list of services, this is the list of pods. And unfortunately, the official Go libraries, they cannot work with WebAssembly yet because they perform all these network operations in the, let's say, usual way. But the usual way doesn't work with WebAssembly because of some current limitation of WebAssembly. But with Rust, you don't face this issue because the official Kubernetes library for Rust is agnostic towards how the I/O is performed, which makes it usable for this kind of experiment with WebAssembly and Kubectl.
Okay, thank you. I don't know if we have any questions on site. Anyone, perhaps? Raise your hand. 3, 2, 1. Okay, I have one last question, if I can. So you just show the decoder WebAssembly plugin. Have you written perhaps other plugins, or just this one?
Well, this is the one. This is most useful one, I think. I have another one which is done for a project I'm working on, which is called Kuborden, which is a policy engine for Kubernetes, which uses WebAssembly. And I wrote a small plugin that is related with Kuborden that is showing events coming from Kuborden whenever something is rejected. But this was more of a POC to prove myself that this idea could work.
Okay, thank you. Seems we don't have any more questions. Can I have again a big round of applause for Flavio? Flavio, thank you so much for your talk. Thank you for joining us.
Thanks.
And hopefully see you in real life soon.
Yeah, have
Bye,
a great
cheers.
day. Enjoy the conference. Bye-bye.
Thank you.